Hi guys, and welcome to lesson 2 on the chemistry topic 5.1 for AQA. So again, sticking with endothermic and exothermic reactions, but today we're going to be looking at an energy transfer required practical, which for chemistry as a separate science is required practical 4, and for the combined sciences is required practical 10. What we're going to be looking at is how we can investigate energy changes in a chemical reaction when we do a practical, why we set up the experiment as we do, and some changes we could make to improve the experiment further. Now, AQA wants you to be able to perform these following skills. So skill 1 it wants from this experiment, from this required practical, is to use the appropriate apparatus to record measurements. So in particular for this one, you might have to record masses of solids. Temperature obviously will have to be recorded for any way you do this, and also you might potentially have to be recording volumes of liquids. They also want you to use appropriate apparatus and techniques for conducting and monitoring chemical reactions, which in this case essentially just means they want you to be able to use a thermometer to measure the temperature of the reaction, and they also want you to be able to use glassware safely and considerately. So, fairly easy. They also need you to be able to record appropriate observations. So in this particular case, again, it goes back to changes of temperature, so much the same as the first two. And they also want you to be safe in your use and handling of gases, liquids, solids, and mixing reagents under controlled conditions. So it's fairly standard stuff. Now what they say the required practical is about is they say you've got to investigate the variables that affect temperature changes in reacting solutions, such as you might have an acid plus metals and then you're going to get a temperature change. Acid plus carbonates, you're going to get a temperature change in that reaction. Neutralization reactions or displacement of metals. Now these are just some examples. They could give you a whole host of potentials in class, and in the exam board, in the exam, your final exams, they could ask about almost any chemical change that gives a temperature change, and the numbers of those are near on infinite, so there is no point trying to learn them all. But the good thing is, if you know the vague idea of how to do one of them, you can apply that knowledge to all the others. So the simplest way to do this is to look at how temperature change is affected by changing the concentration or amount of a reactant. So you can change the concentration, or you can change the amount by the amount. I'm here meaning the mass if it's a solid, or volume if it's a liquid. Now, basic investigation. One of my favourites is reaction between ammonium nitrate powder and water. What you need to do is identify an independent variable, the thing you're going to change. The dependent variable, the thing you're going to measure, so that's the thing that's going to depend on the independent variable. So when you change the independent variable, what are you expecting to change? So in this case, we're measuring energy changes, so we're expecting temperature changes. And we need to be able to identify some control variables and come up with a hypothesis. Now what I want you to do is I want you to have a think. We've got this reaction between ammonium nitrate powder and water. What variables do you think you might choose? Thinking about changing the amounts, changing the volumes, changing the masses. What are you going to choose? What are you going to measure? And what are you going to keep the same? So put the video on pause, have a think about that, give yourself a minute or two, and write down your answers and see what you think. Now I'm going to give you my answers, my ideas in a minute. So, independent variable. So we've got the reaction. Ammonium nitrate, we could change one of either of two things here really, because the ammonium nitrate is a powder, we can't change the concentration, and water is water, again we can't change the concentration. So what we'll be really looking at changing is either changing the amount or the mass of ammonium nitrate, or changing the volume of water. We're using the amount of water. For the purpose of going through this PowerPoint, I'm going to stick with the volume of water. However, both are equally valid. Okay, you could do either of them. The next step is to work out what our dependent variable is. So we're measuring an energy change by temperature. So our dependent variable is simply the change in temperature, and your ways of measuring that is obviously going to be with a thermometer. Now the control variables, they're the things we're going to have to keep the same. So if we're changing the volume of water, we must keep the amount of ammonium nitrate the same. The simplest way to do this is to measure a certain mass of it each time. So for example, 5 grams, 5.0 grams if you're going to be really accurate about it. The more accurate, obviously, the better the results. Ideally, we'd keep the starting temperature of the water roughly the same. It doesn't have to be exactly the same. If your starting temperature of the water is 20 degrees one time and 23 degrees the other, that's not so bad. If it's 20 degrees one time and 40 degrees the next time, then yeah, we've got some issues. So we're going to try and keep the temperature of the water roughly the same, not exactly. The temperature of the room should also be kept fairly constant if possible. Obviously, if you were going to do this reaction and you put your beaker of water on top of a radiator and you've measured the starting temperature at 20 degrees and the radiator's on, that water is going to heat up and it's going to be nothing to do with the reaction. So we need to try and keep the temperature of the room fairly constant to give us the best results possible. There's obvious ways to do this, so don't do it on top of a radiator, don't do it on top of a Bunsen burner, and don't do it next to a really breezy window either. Now, step 4, we need to create a hypothesis. So our hypothesis needs to be, for example, do we think adding more water will make the temperature change greater or smaller? So will it make the temperature change a larger number or a smaller number? What do you think will happen? I mean, it's at this point you maybe don't have too many ideas, so you could maybe use collision theory from topic 4 and think about if you've got more water in this, well, you're not changing the concentration, so is that going to make an effect? Or you might perhaps want to link in with physics and think about how much thermal energy might be absorbed by different volumes of water, and that's the more interesting one for me as a chemist. Now, creating a method. In the exam, you may have to create a method based on your knowledge of required practicals. Okay, so again, this is really important to focus on and to treat as seriously as any of the content learning. So the lessons, the practical lessons you do at school are really, really important, not just because they're giving you practical skills, which are incredibly useful for the chemical industry and if you're going to take your chemistry studies further, but it's also really important to study them because they can be examined. Okay, and it's testing your creative thinking here. A lot of the time people don't think of chemistry as a creative subject, but it really is. The people who do best of it have got a good imagination, they've got good creativity, so this is what it's testing. Your method must be logical, so it should say be in a logical order. You must be able to get results by following the method, so it must suggest steps that would give you some results from a practical. You must say what you're going to measure. In this case, our dependent variable, the temperature change. Okay, so you can measure the temperature change in this reaction. And you must give sensible volumes or masses for our reactants. Okay, don't go and say I'm going to use a ton of ammonium nitrate, because obviously no, you're not. And then give the ranges that you're going to use for your independent variable, and we'll have a look at that in a second. So here's my basic investigation method. So take a polystyrene cup and place it into a 250 milliliter beaker for stability. Now, why do you think we might be using a polystyrene cup? We're using energy changes. Think about why sometimes in, for example, parents' evenings, they often get polystyrene cups of coffee. Why do we give polystyrene cups and not, say, for example, a metal cup for coffee? Then into that polystyrene cup we're going to add our starting volume of water, and you can see here I have given the volume of water, 10 milliliters. Record the start temperature. I don't need to say with a thermometer because that should be fairly obvious. Add in 5 grams of ammonium nitrate powder and stir to dissolve, and you'll notice it says 5 grams. I've given the mass of ammonium nitrate powder, and it's a sensible amount. Both of these are sensible starting amounts. Step 5. Record the final temperature when the temperature stops changing. So when the temperature stops changing, you'll notice the temperature will either keep rising or it'll start falling. When it stops doing that, when it stays steady, that is your final temperature. Then step 6, rinse out the cup. Obviously we need to clean it out and get it ready for the next one. We don't want it to be contaminated with any reactants. Then repeat steps 2 to 6, but increasing the volume of water by 5 millilitres every time until we're using 50 millilitres. So we're going to use 10, 15, 20, 25, 30, 35, 40, 45, 50. We're going to use 9 separate results, which will give us a really clear indication of what's happening. Okay, so I've given here my range. I've given appropriate numbers of the reactants in terms of the volumes and the masses. I have also said what we're going to be recording. Okay, recording the start and the final temperature. I should also say after this I can work out the change in temperature. Here's what your experiment might look like. This is my wonderful skills in paint. So the black thing around the outside is our 250 milliliter beaker, and inside that we've stuck our polystyrene cup, and you will notice there is a gap between the polystyrene cup base and the base of the beaker, and that's there for a reason. We're going to come on to that later. The kind of turquoise liquid is our reaction mixture, blue polystyrene cup, and the green is our thermometer. Okay, so we can stir with the thermometer so long as we're careful, because obviously polystyrene is quite fragile and we don't want to break it. Some things to know then. As I mentioned earlier, I wanted you to think about the polystyrene cup. So it's not only a vessel for the reaction, and it's quite a good one because they're relatively unreactive, but it's also a good insulator, and that's going to reduce the heat transfer in and out of the reaction mixture, which is going to keep our results more accurate, more reliable. The beaker also helps reduce heat transfer because it's going to trap a layer of air underneath and around the sides of the cup, and as we know, air is not a very good conductor of heat, so it's going to reduce the loss of heat by conduction. It's also going to prevent heat loss by convection because the polystyrene cup will hopefully create a seal around the top of the beaker and stop the air escaping, so that air is going to get trapped inside and will prevent the loss of heat. So how could we improve it then? We need to think about that. So think about the heat transfer in and out of the reaction mixture. Think about why we did a polystyrene cup. Think about the fact that the polystyrene cup inside the beaker is preventing the air around the polystyrene cup from escaping out of the beaker. So what could we do to make this experiment even better? Prevent even more heat transfer in and out of the mixture. Simple step, add a lid. So you'll probably notice on travel cups of coffee, they've all got lids on. Then those lids aren't just there for safety, they're also there to try and keep the contents of the cup hotter for a longer period. And you can do an experiment at this at home. If you've got a travel cup of coffee, you can pour in some water, and you've got a thermometer that can measure to 100 degrees. Pour in some boiling water, put the thermometer in, watch the temperature fall, say time it for 10 minutes or 5 minutes, and see what the temperature is with the lid off. You can then put the same amount of water in, put the lid on, leave it for the same amount of time, and measure the temperature afterwards, and you should find that the one with the lid on stays much warmer than the one without the lid. The other thing you could do is you could add more insulation around the sides of the polystyrene cup. Now there's a couple of different ways you could do this. You could add tin foil around the polystyrene cup, which would prevent heat loss by radiation. You could also add things into the beaker, things like maybe cotton wool or wood shavings or things like that, things that are going to act as insulation and trap even more air. So, quick summary then. The required practical is going to involve you investigating how changing conditions of a reaction are going to affect the temperature change in an endothermic or an exothermic reaction, and you will be examined, or it is possible you will be examined on this, so you do really need to pay attention. In the exam, you'll have to be able to identify the independent variable, the dependent variable, and also explain what the control variables might be. You'll also potentially be able to need to be able to suggest a logical method to perform a practical. So it might say, I don't know, Susie wants to perform an experiment. She thinks this reaction is going to be endothermic or exothermic, and changing variable X will make it more exothermic. or more endothermic, suggest a method for how she could do it. And again, you can use this method, the basics of this method, for any reaction that's going to involve either two liquids or a solid and a liquid. And you should be able to look at a method and suggest ways to improve it using your knowledge of chemical experiments and also brain power and a bit of logic and a bit of common sense. As I said earlier, they could give you an almost infinite variety of different practicals, but they're all going to work in very, very similar ways. So a good way to get used to this is just to practice exam questions that are based on experiments and investigations. Anyway, I hope you found the video useful. Please remember to hit that like button if you did. Please drop any questions that you've got in the comment section below. Please remember to subscribe and to share. It really does help. Thank you again to Ploppy for your continued Patreon subscription. Please do share this video. The more viewers we get, is good for me. It keeps me motivated to keep making them. Okay, take care, guys. I hope to see you soon, and I hope lockdown is treating you okay. Bye bye.